Hello, and welcome to section 5.8. Today we're going to look at modeling with quadratic functions. By the time we're done with this section, you should be able to write quadratic functions when you are given certain parts of their graphs, and you should be able to use technology to find quadratic models for a set of data. So we're going to start out with an example. And example 1 says to write the quadratic function for the parabola that's shown. Now, if you notice, your parabola that's been given to you, you do have a vertex point, and you also have an additional coordinate point. So because you know the vertex, you should automatically start to think, what form were we given that had a vertex in it? And I hope you remember that that's called vertex form. So vertex form says that we have y equals a times a quantity of x minus h squared plus k, where h and k are the coordinates of the vertex. So let's go ahead and plug in our coordinates. So we have y equals a times x minus h is going to be the x coordinate. So I'm going to plug in a -2. That quantity is going to be squared. And then I'm going to add the y coordinate from the vertex, which is my k value. So I end up with plus 1. Now, when we simplify this, we have y equals a times a quantity of x plus 2 squared plus 1. So we're getting closer, but we still don't have a completed quadratic function because I have too many unknown variables. I don't know what a is, for instance. So in order to solve for a, I'm going to use the additional point that was given so that I can solve for that value and write my final formula. So I'm going to take this coordinate point right here and plug it in for x and y. So my y value out of that coordinate point is -1, and -1 is going to be equal to a times the quantity of, I know that x is 1, and I'm going to be adding that to 2. I'm going to square that quantity and add it to 1. So when we go to simplify, we have -1 equals a times 3 squared plus 1, which is really -1 is equal to 9a plus 1. If I go ahead and I subtract this value right here so that I can start to get a by itself, we end up with a -2 is equal to 9a. And if I go to get a by itself now, I'm going to divide both sides by 9, and I see that a is equal to a -2/9. So now that I know what a is, I'm going to take this value and plug it into this equation, and we will be left with y equals a -2/9 times a quantity of x plus 2 squared plus 1. Now before we submit this as our final answer, let's do some double checks. First of all, let's check our vertex, make sure it's still the same. I have a +2 here, and it looks like that's because my vertex is a -2, so that's correct. We have a +1 here, which is the y coordinate of our vertex. That's correct. And then the other thing we need to double check is I ended up with a negative coefficient. Well, a negative coefficient, remember, is going to tell me that my graph or parabola is going to be downward facing. So when I come and I look at my graph, I notice that it is downward facing. So I think I'm okay to accept that this is probably a pretty good representation of the above graph. Now example 2 is similar, however it is slightly different. Example 2 says to write the quadratic function for the parabola that's shown. However, this time I'm not given the vertex point. I am given a coordinate point, but it's not the vertex. And unless you're given that point, I wouldn't assume that it's anything. You need to be really sure of what the vertex is if you're going to use a vertex form. So even though I'm not given the vertex, I am given a point here, and I see that I have two x-intercepts that actually go through a nice number. And by a nice number, I mean that I have the vertex, or I'm sorry, an x-intercept of 1, 0, and 4, 0. So ultimately, because I'm given two x-intercepts, I can actually use the intercept form of a quadratic function and plug in what I know. So we end up with, well, I guess let's take a step back. Intercept form is really y equals a times a quantity of x minus p times a quantity of x minus q. And recall, p and q are just the x-intercepts. So if we go ahead and just plug in our x-intercepts, we have y equals a times a quantity of x minus 1 times a quantity of x minus 4. So now I am close, but again, I'm not quite where I need to be done. So I need to solve for this a value here. Well, I can do that because I'm given a coordinate point on that parabola. So I'm going to plug in my x and y values from that coordinate point so that I can make a general equation. So let's go ahead and do that. I see that we have, negative 6 is equal to a times a quantity of, when I go to plug in 2 for x, we end up with 2 minus 1 times a quantity of, again I'm going to plug 2 in for x, minus 4. When we simplify, we have negative 6 is equal to a times 2 minus 1, which is 1, and 2 minus 4, which is a negative 2. So when we simplify one more time, we get negative 6 is equal to a negative 2a. And to solve for a, we're going to divide by a negative 2, and we get a value of 3 for a. So now all I have to do is take this a value and plug it in up here, and we are given that y is equal to 3 times a quantity of x minus 1 times a quantity of x minus 4. And again, before we accept this, let's just do some quick double checks. I have two vertex points. If I set these equal to 0, I should get a positive 1 and a positive 4, which is what I have for x-intercepts. So that looks good. I have a positive 3 here, which would tell me my parabola would be upward facing, which it is. So I'm at the point where I could say this looks like it would be a pretty acceptable equation. Now example 3 says, a group of students dropped a rubber ball and measured the height in inches for each successive bounce. The results are shown in the table, and you want to find the quadratic model in standard form for the data using the first 3 points. Because it said that you want to write a quadratic model in standard form, you have to know that standard form is y equals ax squared plus bx plus c. And if I'm using the first 3 points, what I can really do is I can turn these first 3 points into coordinate points. So I'm going to have the coordinate point 1, 47, 2, 39, and 3, 26. So in other words, just to kind of explain what the data means, it says my first bounce went 47 inches, the second bounce went 39 inches, and the third bounce went 26 inches. So what we're going to do to solve this is we're actually going to write 3 separate equations, and we're going to use these coordinate points to help us out. So let's start out with the first one. My first one, I know my y value is 47, so I'm going to plug that in to my standard equation. I don't know what a is, but I do know what x is. So I'm going to have a times 1 squared plus b, and again I don't know what b is, but I do know what x is, and plus c, which is just some constant. And I'm going to do the same thing for my second equation. My second equation has a y value of 39. I still don't know what a is, but I know that x is 2, so I'm going to square that. I'm going to add it to b times 2 and add that to c. Likewise, I'm going to use my third point, which has a y value of 26. So 26 equals a times 3 squared plus b times 3 plus c. Now I can take all of these and simplify them. So let's just rewrite these over here. And we end up with a plus b plus c equals 47. Then we have 4a plus 2b plus c equals 39. And then we end up with 9a plus 3b plus c equals 26. And at this point, what we've come up with is a set of 3 equations with 3 unknowns being a, b, and c. So from, I think it was chapter 4, when we were dealing with matrices, if I have 3 equations and 3 unknowns, I can either solve them where I do substitution, or we can go ahead and just use matrices. And if I set this up as a matrix, my coefficient matrix will be 1, 1, 1, 4, 2, 1, 9, 3, 1. I'm going to multiply that by A, B, and C, and this is going to equal my constants, which was 47, 39, and 26. Now I've got something of the form AX equals B, and hopefully you still remember that if we have the format of AX equals B, all I have to do is go A inverse times B, and I'll come up with my X matrix, which happens to be my variables. So why don't you put the video on pause, take a few seconds to do that, and see if you come up with the same thing that I did. Okay, now that you've done that, hopefully you found that A was equal to a negative 2.5, B was equal to 0.5, and C is equal to 50. So let's go ahead and plug this into our formula because it wanted an equation in standard form. So this is going to tell me that I have an equation that says y equals a negative 2.5 x squared plus 0.5 x plus 50. And again, before I submit my answer, let's think about what this means. I have a negative a value, which tells me that I would have a downward facing parabola. And if you think about this, when we drop a ball, let's say you're dropping it, it's going to look something like this. It's going to go down, and then it's going to bounce. And then it's going to bounce a little bit less, and then it's going to bounce a little bit less. So I really do have parabolas, and they are downward facing, which seems feasible. Now this value right here, as we've mentioned earlier this week, this is our initial height. So does it seem reasonable that you would drop something from a height of 50 feet? And I would hope you would say yes. So at this point, I think this is pretty feasible, so I am going to submit that answer. And I do have just one little correction. This B value should have been negative, so I do apologize for that. So B should be negative. And now for our last example. Our last example says that we're going to use a calculator to find the best fitting quadratic model for the data. And I'm going to tell you, like I did when we were doing linear equations, you can use your calculator, but you have to know how to do this by hand. I will give you 2 different problems just like I did on the linear equation test. One you'll have to do with a calculator, one you'll have to do by hand. So please make sure you know how to do both methods. So, for example 4, we're going to take our calculators out and we are going to enter this list of data. Now remember, our bounce is going to be our x values, our height is going to be our y values. So with your TI-83 or TI-84, what you're going to do is you are going to go to the Stat menu, And remember, stat is the second, it's the third button over from the left, second button down from the top. Then we're going to select the first function, which says edit, and I have to edit my list. And once you hit edit, you should see that you have a column of L1, L2, L3, and so on. So it's going to be at this point in time that we are going to put in our data, and I'm like on my screen here, I see that I have L1 and L2. L1 is going to be my X values, L2 is going to be Y. Now, if your calculator says something like L2 and L3, that's okay. Can just put them in, L2 is your X, L3 is your Y, and I'll show you how to fix this here in just a moment. Once your data has been entered, we are going to go back to the Stat menu. And this time, instead of going to Edit, we're going to slide over to the Calc menu. And under the Calc menu, you'll see that you have one variable stats, two variable stats, medians, linear regression, quadratic regressions, and so on. What we want to do is we want to go down to the quadratic regression. So it says QUAD and then REG. And we're going to hit enter. And what a quadratic regression is doing is it's going to take the data that you just entered and it's going to fit a nice kind of curve that's going to kind of accommodate all of that, kind of like a line of best fit. And at this point in time, you should see on your screen that you have QUAD REG. Now before we hit enter again, we're going to go in and we're going to tell it which data we want it to look at. And now I'm going to hit second stat. And I'm going to hit second stat, and what you should see on your screen is you have L1, L2, L3, and so on. So if you use L1 and L2 for your X and Y values, now we're going to go L1, hit enter, and then I'm going to have to type in a comma, and the comma comes in right above the number 7, and then I'm going to go back to my second stat, and then I'm going to pick L2. Now if you use L2 and L3, you're going to select L2 first and L3 here, or whatever list you've got there. Now that you have told your calculator to take the quadratic regression, and you've told it which list you want it to take the quadratic regressions of, we are going to hit enter. When you hit enter on your screen, you will see something that looks like, it will say quad REG at the top, then it will give you that y equals ax squared plus bx plus c, and then it will tell you that a equals a negative 2.5, b equals a negative 0.5, and c equals 50. So to come up with your final equation, what we're going to do is we're going to take this negative 2.5, plug it in for A, this negative 0.5, plug it in for B, and 50 in for C. And what you should notice is this is the exact same equation that we got back in example 3. And last but not least, we had this second part here that says, according to the model, when did the ball reach a maximum height? Well, remember, your maximum height is coming from your vertex. So in order to calculate our maximum height, we're going to have to calculate the coordinates of our vertex. So our vertex, and let's just rewrite our equation, we have y equals a negative 2.5 x squared minus 0.5x plus 50. So to calculate our vertex, we're going to take x equals the opposite of b divided by 2a, and the opposite of b is going to give me 0.5 divided by 2 times a negative 2.5. And when you simplify that, we end up with 0.5 divided by a negative 5, which is equal to a negative 1/10. And this negative 1/10 is really my x value. I want to know the height, which is my y value. So to find my y value, I'm going to take this negative 1/10 and plug it into this equation. So I end up with y equals a negative 2.5 times a negative 1/10 squared minus 0.5 times a negative 1/10 plus 50, and when you do that, you end up with 50.025, and this was all done in inches if you go up and look at that original table. So you'll notice that your ball actually went a maximum height of a little bit over 50 inches. And it will be at this point that we conclude section 5.8. If you have any questions, I will be back on Monday, and I hope you guys have a great weekend. Thank you.